let's talk about factoring polynomials. So last lesson we did multiplying polynomials, which is where we have two polynomials. We multiply them together to get one. Now we're going to be working backwards. We have one polynomial and we want to break it up into two. Okay. So the very first thing that we are going to try every time we factor is the greatest common factor. So in this polynomial, we're looking for, in each term, some factor that's in common, okay, some part, okay. So for example, we'll look at the numbers, okay, 6, -9, 12. Is there something that goes into each of these numbers? And there is 3. Okay, so 3, we'll write that, that's part of the greatest common factor. And then we'll look at the variables, okay, m, there's m in every single one. How many? There are 4 in this one, 3, and 2. So there are at least 2 m's in each term. So 3m squared is the greatest common factor. Now we are going to factor that out of this polynomial. Okay? And the way we're going to do that is by dividing each term by the greatest common factor. So if we divide 6m to the 4th by 3m squared, we have 2m squared left over. And if we divide -9m cubed by 3m squared, we have -3m left. And then if we divide 12m squared by 3m squared, we have 4m, or just 4. All right, and that is how you can use the greatest common factor to simplify your polynomial. So in this case, we now have two polynomials, one monomial, one trinomial, that are being multiplied together. And if we would distribute this back in, we'd be back to where we started. All right. Great. So let's look at another way. The next way of factoring is reverse FOIL. Okay, so we talked about FOIL in the past. That's where you have two binomials. Let's see if this will write. You have two binomials and you multiply the first terms with the first term, the outside terms, the inside terms, the last terms. Okay, that's called FOILing. First, outside, inside, last. And we're going to do the opposite of that. Okay, we're going to work backwards. Same idea, but backwards of that. Okay, so let us start. We know the format of what we want our answer to look like. We want it to be two binomials. Okay, we're going to have something here, here, here. Okay, and then the pattern of this is that the first terms, let me get a different color here. If we multiply the first times the first, okay, that is going to give us this number right here. And if we multiply the, let's use green, if we multiply the last times the last, that's going to give us this term here. Okay, so we know that this times this has to give us r squared. Let's start there. So if it has to give us r squared, then it's probably going to be r times r. Okay, it could also be 1 times r squared, but that's a lot less likely. So let's try r times r. Reverse FOIL is all about trial and error. Okay, it's going to be it's going to take a lot of practice. The more you do it though, the more your brain will start to see patterns. And so this is just something you need to pull out some worksheets, do a lot of practice with this, okay? You can do extra practice on Math Excel using the study guide anytime. All right, now this times this has to give us 10. So how could we do that? We could have a 1 times a 10, or we can have a 2 times a 5. Okay, either way, we don't know, so we're just going to have to try it. And maybe you're jumping already and saying, okay, well, it's this or it's this. Well, let's try a 1 times a 10. And if we do a 1 times a 10, do we want a positive 1 and a positive 10? How do we know? Well, we have a positive 10 here, so we're either going to have 2 negatives to make a positive or 2 positives. Let's try 2 positives, okay? And then the way we can check to see whether this is the right answer is by multiplying the outside and the inside and adding them together. So the outside, we get 10R, and on the inside, we get 1R, and 10R and 1R is 11R, and 11R is not the same thing as 7R, so this is not the right answer. Okay, this is wrong. So we're going to have to try something else. All right, so we tried this. We could try changing this to a negative and a negative. That's one thing. We could try different numbers. Let's go ahead and try different numbers. So for example, let's try 2 and 5. Positive 2 and positive 5. We could also try negative and negative. Now when we multiply the outside, we get 5R, and the inside, we get 2R. When we add those together, we get 7R, which is the middle. So this is the right answer. All right. Awesome. Good. Got it. Okay. Let's go on. Let's try to factor this, okay? You may not be able to immediately see the pattern, and that's okay. It's just going to take some time to form these ideas and patterns in your mind, okay? Something that just takes time to get used to. That's okay. So let me just walk through it rather quickly, and if you're not sure how it works, then just practice and come back and watch it again. Okay, so we know that the first two places have to multiply to give us y squared. So we're going to do y and y. And then over here and here, we want to have two things that multiply to give us 8. So we can have 1 and 8. Sometimes it's helpful to just write out the options, 2 and 4. And that's about it, 1 and 8, 2 and 4. And we want them to, when we multiply the outside and the inside, to add up to 6. So we're going to try positive 2 and positive 4, because positive 2 and positive 4 multiply to give us 8. And when we multiply the outside, we get 4y. When we multiply the insides, we get 2y. And when we add them together, we get 6y. And 6y is the middle that we need. All right. So this is the deconstruction of this polynomial. If we FOIL these two polynomials out, we will get back to where we started. Okay. Here's a little bit more complicated one. Same idea though. We want two binomials that multiply to give us this trinomial. So if we look at this, we need two things that multiply to give us 6p squared. We have some options. We could have p and 6p. We could have 2p and 3p. Let's first try 2p and 3p. Okay, we may have to come back and change it, but we're just going to try it. And then we need two things to multiply to give us q squared. Negative 5q squared. So we could have negative q and 5q. We could have positive q and negative 5q. And I think that's about it. Okay, negative 5q. I think these are our only options. So let's try them. We know this is where we can kind of use our intuition a little bit. We know we want a negative, we want a positive number here. So let's go ahead and try negative q and positive 5q. That way we can hopefully get a positive number in the middle. And we can place the negative q here or here. We don't know which. You probably will just have to get a feel for it. All right. I'm going to put the 5 here and the negative q here. And the reason I did that is because I know that if I multiply the inside times, this is a bigger number, 3 is bigger, then I want a positive number in the middle. So I chose to put the 5 with the 3 to get the bigger number. You'll see how it works out. So let's try the outside just to double check ourselves. Negative 2pq. And let's try the inside. We get 15pq, which is a much bigger number than 2. Oops, this should be a p. All right, and then whenever we add them, they're like terms. Notice how they are like terms. That is very important. We get 13pq, which is the middle that we want it to have. All right, so this is the right answer. Okay, great. All right. Now, there are some patterns that we have whenever we're factoring, okay? And these patterns are things that pop up. You'll see things like if you need to factor x squared plus 2xy plus y squared, or something that has this pattern, then you know that it factors to x plus y times x plus y. And you'll see these things pop up. I don't think that these patterns are worth memorizing, except with the important exception of this one. This one is called the difference of squares, and it is important. Okay, it's called the difference of squares because we have something squared minus something squared, okay? So we have two squareds, and we're taking the difference. Difference means subtraction. So we're taking the difference of two squares, so it's called the difference of squares. And it is important. You'll see this pattern all the time. So if you're subtracting two things that are squared, you say x minus y, or the first thing minus the second thing, and then x plus y. First thing plus the second thing. All right, so we will work with this pattern in 1 second. There are two more patterns here for you. These two patterns in particular, if you need to use them on a test or a quiz or something, I will expect you to know how to use them, but I won't expect you to have them memorized for this class. So I'll either give you the formulas and you'll have to decide which one you want to use and how it works, or there will be some other way that we'll go about it. But I expect you to definitely know how to use the formula, but not necessarily come up with it on your own. The other ones on this page, I do expect you to be able to factor this, but I don't expect you to memorize these two formulas. The top one you should memorize because we use it often. So you may want to take a screen capture, especially of this page, or maybe even of this page, so that you can reference it whenever you're doing your homework. All right, let's move on. We want to factor this. This is 9 beta squared minus 49. Whoa, beta, Greek letters. Okay, is this going to be able to be factored just because there's Greek letters in it? Yeah, it'll be fine. This is a difference of squares. So difference, remember, means subtraction. So we need something squared right here and something squared right here. Can we rewrite this as something squared? Sure we can. This is 3 squared, and this is beta squared. Okay, 3 squared, beta squared. And this is 7 squared. Okay, and remember that this can be rewritten as 3 beta squared. It's like factoring out the exponent, in a sense. Okay, so we have something squared minus something squared. And the formula or the pattern is the first thing minus the second thing times the first thing plus the second thing. All right, so this is the factorization of this. Okay, and if you didn't memorize the formula, you could still work this out using the reverse FOIL method that we talked about before. Okay, same thing, it's just really fast and easy whenever you have the formula memorized. Okay, I think that's it for these pages. Let's work on some examples. Factor the polynomial 8b cubed plus 27. Okay, so 8 can be rewritten as 2 cubed, and then we have b cubed, and 27 can also be rewritten as 3 cubed. So we have a bunch of cubed things. This, just like when we had the difference of squares, can be written as 2b cubed. It's like factoring out the exponent, plus 3 cubed. So we have a sum means addition, of cubes. Okay, let's go back to our patterns. All right. Oops, they are not there. We had one that said a cubed, or it was x cubed, but in this case, I'll just keep going with a. A cubed plus b cubed is a plus b times a squared minus ab plus b squared. Okay, so let's use this formula. In our problem, in our problem we have 2b here, and we have 3 here. Okay, so our a is 2b and our b is 3. So everywhere we see an a, we're going to replace it with 2b. 2b squared minus 2b. All right, and everywhere we see a b, we're going to replace it with a 3. Plus 3, 3, 3 squared. Okay, so just replace each b. So, yeah, let me highlight just so we can be really clear. Everywhere we see an a, we want to replace it with a 2b. And everywhere we see a b in the formula, we're going to replace it with a 3. All right, so then we can simplify our formula, and we get 2b plus 3 times 4, because 2 squared is 4, b squared, minus 2 times 3 is 6b, plus 3 squared is 9. All right, so this would be the answer that you would type in for this problem. Okay, great. Let's go ahead and clear this and go on to number 10. Okay, this one might be a little bit overwhelming. What do we do here? We have 9m to the 6th minus 25n to the 4th. First thing we should check is greatest common factor. Do we have a greatest common factor here? Is there anything that goes into each term? No. Well, then maybe we should check, do we have a difference of squares? And in this case, we do have a difference of squares. This can be rewritten as 3 squared, and this can be rewritten as m cubed squared. So let me write that out. 3 squared, and this is m cubed squared. And then 25 is 5 squared, and into the 4th is n squared squared. Okay, this might be the confusing part. Why can we rewrite this? Do you remember your exponent rules? M to the 3rd power raised to the 2nd power, you multiply the exponents. So m to the 3 times 2, which is 6. So this m to the 6th is the same thing as m cubed squared. And over here, same thing, n to the 2 raised to the 2 again, you multiply. 2 times 2 is 4. So it's a little bit of deconstruction, maybe not the most obvious thing, but we know we're trying to aim for a difference of squares, so if there's a way to write it as a square, that's what we want to do. And there is a way. So we have 3m cubed squared, because this is squared and this is squared, so we can write them together squared, minus 5n squared squared. Same thing. This is squared, we can write them together. So when we factor, we get the first thing minus the second thing, 3m cubed minus 5n squared, times the first thing plus the second thing, 3m cubed minus plus 5n squared. All right, and that is as factored as that gets.